Hello, good morning to all of you. Myself Venkatesh Jadhav, Department of Biophysics, Digambara Bindu College, Bhokar. Today we are going to discuss physical properties of water. The physical properties of water differ markedly from those of other solvents in different ways. If you take an example as water as a hydride of oxygen, that is H2O, has a highly melting point, boiling point, and heat of vaporization with surface tension than do the comparative hydrides of sulfur or H2S and nitrogen in form of ammonia or NH3 and most other common liquids with a different melting point, boiling point, heat of vaporization, heat capacity, that is calculated in calories per gram, heat of fusion again calories per gram, surface tension and dielectric constant are represented in a given table. So these unusual properties are a consequence of strong attraction between adjacent water molecule which gives liquid water great internal cohesion. So this is an inbuilt, or we can say a property of water due to strong attraction between water molecules, and which is creating the tendency of internal cohesion. So the more descriptive table for physical properties of water and other common liquids are illustrated in this table. In humans, about 60% of red blood cell corpuscles. In humans, about 60% of red blood cells and 92% of blood plasma are containing of water. About 75% of most other tissue comprises of water. The only exception are such relatively inert tissue as hair, nail, and the solid portion of bone. So these are the some exceptions in our body cells or tissue which is having a low amount of water. So water is also an principal constituent of the environment in which organisms are surviving. Water has some unusual properties of physiological importance which are in more detail are explained below. So basically there are four important and which are governing and unique properties to physical properties to water. These are we are discussing in detail. So these four properties are expansion on freezing. Again, it has a uniquely high surface tension. Third one is unique high heat capacity of water, and fourth one is high solvent property. So these unique properties or these four basic properties are giving a uniqueness to and water. So if we start one by one in detail, so first one we will consider expansion on freezing. So the most substances decreases in volume and hence increase in density. So as it is a in contrast, and as their temperature decreases. So I am repeating again, the most substances decrease in volume as their temperature decreases. But in case of water, there is an temperature at which its density exceeds that at a higher or lower temperature. This temperature is 4 degrees Celsius. In fact, water just above the freezing point is heavier than water at a freezing point. So it can be explained or we will see its explanation with water and ice form. Therefore, it moves towards the bottom. Freezing begins at a surface and the bottom is last to freeze. Organisms living at the bottom of freshwater lake are hence protected from freezing. It may, however, be concluded that from this overall above description, we can conclude that first one, we can say while almost all substances contract on cooling, water expands. So this is one of the contrast property. If water could contract on cooling, it would have become heavier and would have shrunk. So this shrinking property, and thus all water on earth would gradually have become ice. So this is what the first conclusion. Second one, or B, we can say when temperature of water is rise above 0 degrees Celsius, its volume decreases up to 4 degrees Celsius and thereafter increases. Water has the minimum volume and hence the maximum density of 1.00 at 4 degrees Celsius. So this is the density upon increasing temperature up to 0 degrees Celsius. The volume of water at 4 degree Celsius increases either on heating or cooling it. So this is what second conclusion, when temperature of water is raised or increased. Now third conclusion, while all substances increase in volume when they are melt, the volume of ice decreases when melt. Volume of 1 gram of ice is 1.09 cc, that is cubic centimeter, but when it melt into water, it occupies only 1 cc. So here is we can say there is a decrease in cc by 0.9, and so from this third conclusion we can say that where all substances increases in volume when they are melt, but the volume of ice decreases when it melts. So the fourth conclusion or last one, we can say frozen water is less dense than liquid water. So as or generally what we are considering, or we can assume, or generally anybody can think the frozen water is looking, or it is in a solid form. So by looking at water and ice form, we can easily predict frozen water is it will have a higher dense, but in case of water it is completely reverse, that is frozen water is less dense than a liquid water. So this is what the 4 basic conclusion we can draw from expansion on freezing property. Now the second property is unique high surface tension. Second property, uniquely high surface tension, is explained as like a stretched membrane, the surface of a liquid tends to contract as much as possible. This phenomena is like or is known as surface tension. Water has the highest surface tension of any known liquid. So it is about 72.8, so which is the highest among known liquids, and it is the reason why water rises to unusual high levels in narrow capillary tube. So the capillary action shown by water is due to its high surface tension property. As most of you know, the rise of liquid in fine borough or fine diameter capillary tube. So this has a great significance in physiology. So how it is significant in physiology? As we know, there are different body fluids, or solvent for different body fluids is water. So their movement, their circulation, their regulation, their maintenance of fluidity is due to this surface tension property. So as we know, the blood flowing in a capillaries or blood capillaries, so where water is a maximum or a major component of and blood, so their flow, their dynamics of and movement from heart and to the heart to the different cell tissues of body is due to this surface tension property. So we will discuss in more detail in physiological biophysics of this same course. Now third most unique property of physical property of water is a high heat capacity. There occurs a small temperature rise in water as compared to most other substances when a given amount of heat is applied. Thus, water acts as a temperature buffer. It maintains its temperature more successfully than most other substances. We may thus say that has a high heat capacity. So, if we take an exact value of heat capacity of water, it is around 1000 calories per gram. So, this is a very again a unique property, physical property governed by and water. So for further, again high solvent power is and fourth physical property of water, where water is a solvent for a great number of molecules which forms ionized solution in water. It may thus be called a universal solvent which facilitate chemical reactions both outside of and within biological system. So there are different forms of water inside a cell, outside cell, in microenvironment of cell, or in an environmental water bodies of and the surrounding or nature. This water is playing a important role, or it is also known for its solvent of life property. Now if we take some of the water and its future, so as if we take an property and what will be their chemistry and results. So first feature of water or property, you can say universal solvent, because of its chemistry is polarity and it facilitates chemical reactions. So second, it adheres and is cohesive. So again this property is governed by polarity, or more specifically we can say it is due to hydrogen bonding. and therefore it is acting as a transport medium. Now third property, resist change in temperature, which is again governed by hydrogen bonding, helps keeping body temperature constant. So fourth most important, that is resistant change of state. So what it is resisting change of state, such as from liquid to ice, from liquid to steam. So it is again governed by a hydrogen bonding. So or at large scale, how it is useful in environment. So it moderate the earth's temperature, the planet earth, and its temperature, or this climatical temperature, is maintained by this property of water. Again, less dense as ice than as liquid water. So which is again a maximum 4 hydrogen bond is providing ice state form. And as a result of this as ice is floating on water, so it is from this you can clearly get an idea that ice form of water is a less dense form as compared to a liquid form of water. So basically there is a rearrangement of and the hydrogen bond in liquid form of water and in ice form of water. So basically cohesion, or if we talk about some cohesion among water molecules, where a cohesion among water molecules allow water striders to stick across the surface of still water. And in Ghent or redwoods, cohesion holds water molecule together in continuous strands from the root to the topmost leaves, even 100 meters above the ground. So in most of physiology also, or in in miracles of nature also, we have most of the time we have put this an example as why there is no hurt in a plant to transport water, as we are having hurt to transport a blood, but how the water is transporting from root to tip without any force or without having any organ to pump this water. So this property, cohesiveness of water, is and very playing an important role in transport of water in a physiology of plants. So plant water transport is an best example to explain the cohesive property of water. So it is we can say due to cohesive property of water molecules that allow water striders to stick across the surface of still waters and empower redwood to raise water on and about 100 meters above the ground. So if you take an example of redwood plant, so hundreds of meters of water is raised against gravity with the help of or due to this cohesive property of water. So with this we will take a small revision for physical properties of water. And this water basically has 4 unique physical properties. First of all is an expansion of freezing. Second one is uniquely high surface tension. Third one is unique high heat capacity of an water. Then last one is an high solvent power, or how water is an universal solvent is explained with water and its features. So, with the example of some plant water transport, we have elaborated more one of its property in a biological system. So, with this, we are concluding here physical properties of water. In next lecture or in next session, we will discuss about structure of water molecule and how the chemical bonds and the atoms within molecule are arranged at what bond length, bond angle, and with what chemical or electronic configuration they are combined together to make this molecule as an universal solvent. So thank you for attending the session.